every time you just wait for me to tell you what to do, yeah, you'll do fine when we're working together, but you won't do very well when you're trying to work by yourself. Because I'm not going to come around during the assessment and tell you this is what you should do. So as we do a couple problems, the next step is for you to do more problems, which is why there's more problems in the packet, and to try using the strategies yourselves. But I'm going to talk about my thinking for these first few problems to model for you how to attack them. Okay, so when I look at the problem number 1, cosecant times sine, and I think, all right, I want to try to write that a different way. My number 1 strategy is always, can I write things in terms of sines and cosines? So when I look at this problem, I think, well, cosecant is the same as 1 over sine. And so instead of having a cosecant times a sine, I'm going to change this problem into 1 over sine times sine. And maybe I'll write that second sine over 1. Now, you may have seen this coming, or not, but then now you're like, oh yeah, look at that. If I have 1 over sine times sine over 1, that means I would get a sine over a sine, and anything over itself is 1. So my first expression, cosecant times sine, simplifies to just a 1. I want to rewrite the problem that's there in the simplest form possible. And I can't get any simpler than just a whole number. Okay, so all the way down to a whole number, that's awesome. Down to just a single trig function is also a good indication that you're done. Now, that's not the only way to do that problem. I could change sine into 1 over cosecant, and it would have happened the same way. I could do other things in this problem that are not as easy, that would, take us like crazy trips around different ways. But if I'm doing steps that are correct, no matter what steps I do, I should be able to always end up at the same place. Okay. When I simplify something, every different form of it should end up at one universal most simplest form, which is in this case a 1. Okay, let's use a similar strategy for number 2, which is write everything in terms of sines and cosines. So when I look at this originally, I see a secant, I see a tangent, and I see a sine. I'm going to leave the sine alone if my goal is let's go sines and cosines, and I'm going to change the secant, and I'm going to change the tangent. Go ahead and try something for that. Look at my list of identities. What can I do with a secant? What can I do with a tangent? If what we're shooting for is maybe all I want to see in this problem are sines and cosines. All right, suggestions. What can we do with secant? We can use 1 over cosine. So 1 over cosine to change the secant. That's a good plan. Now, tangents are tricky. Tangents and cotangents, because a lot of times you can go two ways. Tangent, we could go to the reciprocal list and we could go to the quotient list. Okay. If I'm shooting for sines and cosines, I'm probably going to go to my quotient list. So I'm going to change tangent into sine over cosine. Now, we might not see how this is going to be simpler yet. We're just kind of investigating. I'm going to leave sine as sine. So technically, that's a simpler expression because it's only got 2 different functions in it instead of 3 different functions. The less functions we have, the more simple it's considered to be. So even though it looks a little scarier because you have fractions, instead of having a secant and a tangent and a sine, I've got all sines and cosines. Now, a sine and a sine make a sine squared. A cosine times a cosine makes a cosine squared. This is our number 2 identity that we have to look for. When I've got a sine over a cosine, and they've got the same power, a sine over a cosine is a tangent. So a sine squared over a cosine squared is then a tangent squared. That's one of the tricky things about some of these identities. The quotient list works for other powers, other exponents. These guys work for other powers. But these guys only with squares. Okay? So other exponents work for these guys. So you can do like sine squared over cosine squared, cosine cubed over sine cubed is cotangent cubed. You can have any different powers. Whatever the powers are here would be the power there and vice versa. Same things here, secant squared, 1 over cosine squared, tangent squared, 1 over cotangent squared. You can have other powers of the reciprocal and quotient identities, but you can't have anything else, any other exponents besides the squares on the reciprocal, or on the Pythagorean identities. Okay. So, a bunch of stuff multiplied together, like a chain of stuff multiplied together. Number 1, it was just 2 things multiplied together. Number 2, 3 things multiplied together. Bunch of stuff multiplied together. All sines and cosines usually kind of helps. Things might cancel out, or you might be able to start combining things, and that's usually a pretty good strategy for simplifying. Okay, next chunk. When I see things that are squared and ones, squares and ones, I think Pythagorean identities. A secant squared and a 1, a cosine squared and a 1, okay, a sine squared and a 1, a cosine squared and a sine squared. Any of the little individual pieces that are in the Pythagorean identities kind of tips me off that might be what I want to use. Now, most of the time when we're doing a Pythagorean identity, okay. He kind of went in reverse there for a minute. All right. So when we're doing a Pythagorean identity, a lot of times we're taking there's a lot of times there's more than one way to attack it. So when I look at this, I kind of think, man, is that a version of my identity? So if I remember that I have an identity that says 1 plus tangent squared equals secant squared, okay, if I remember that, then I can use algebra and just rearrange that and get that tangent squared is equal to secant squared minus 1. That's just me taking this guy and subtracting 1 from both sides. So I leave the tangent squared all by itself and I move the 1 over here, and so I subtract 1 from the secant squared. So this version gives me that version. So that means I'm like, oh yeah, and that's what I see here. So this guy is just a tangent squared. Okay. I'm asking you to write it a different way. If I'm asking you to write it a different way, that means there's a different way to write it. I'm not going to ask you to simplify something and then be like, haha, tricked you. There's nothing you can do. Okay. We're practicing simplifying. So if I say, you're going to simplify for me, that means there must be something you can do to it to write it in a shorter way. Not having a subtraction, having just a single function versus a subtraction of terms is considered more simple. So secant squared minus 1. Another way to write that is just as a tangent squared. Okay. If you don't recognize that, or another option, if you remember that if you're thinking Pythagorean identity and you think that, okay, I'm over here doing my thinking, and in my thinking I remember that 1 plus tangent squared equals secant squared. That's another thing I could do. I could take secant squared out. I can replace it with 1 plus tangent squared. And then that one and that one would subtract away, and I would still end up at tangent squared. You gotta kind of mess around with it. It's not like I said, you can't just stare at it and wait for the miracle to occur. The knowledge is not just going to pop into your head of what to do. And it's not obvious. You're not like, oh yeah, I can totally see exactly why I would think that. You have to practice doing these problems, so you are actually practicing looking for different ways to write things. It's like taking a paper and consciously going through it and changing your vocabulary, finding different ways to say what you mean. We are finding different ways to re-represent certain problems, and our goal is, at least this first time through, to just try to make it as simple as possible. Now, it's a lot easier, it'll be a lot easier in our next class when we start having a very specific goal. When I say, hey, here's what it looks like. Make it look like this. That's a lot easier. That's essentially all we're going to do when we do a proof, is I'm going to say, show me that this scary looking thing is the same as this simple thing. And then you're going to show me, oh, look, if I take scary guy and go blah, 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 he'll match. Right now, we're just practicing doing the changing parts, but we don't really have a goal, a huge goal of where we want to end up. That makes it a little tougher. All right. Suggestions on number 4. Okay, if I take out the 1, what could I put in place of the 1?
Cotangent square. Right?
In
The cosine over
Oh, okay. I understand what you're saying. So the problem is, I understand that. So cosine squared over sine squared would be cotangent squared. But the problem is the 1 also would have sine squared. If we were going to write this as fractions, it would be 2 separate fractions. Okay. So where I like what you said, cosine squared over sine squared could make a cotangent squared. That wouldn't get rid of the 1 part. Okay. So this is one thing you could do. You could split this into 2 separate fractions. Both of those fractions would have the same denominator. And so I would have 1 over sine squared, and I would have cosine squared over sine squared. And Bizzarri is 100% right. A cosine squared over a sine squared is a cotangent squared. This isn't necessarily a Pythagorean identity, but it's definitely a way we could do this problem. Let's say we kept going this way. What's 1 over sine squared? What can I do with that?
Cosecant.
Okay, so that's a cosecant squared because it's a sine squared. So now maybe I'll get, that kind of looks like my third Pythagorean identity now, just rearranged a little bit. Okay. A cosecant squared and a cotangent squared, and I'm subtracting them. Well, I could change, if we want to think about it this way, my cosecant squared, I could write it as a cotangent squared plus 1 minus a cotangent squared. And so, yeah, I think that one's going to come out to be 1. I actually had a totally different idea in my head, and we'll look at that way too. That's what makes these problems fun and crappy all at the same time. They're fun because they're kind of like puzzles if you kind of like that thing. And they're crappy in that there's lots of ways to do them.
I'm really lost in how this was. Like, how is it cotangent square x plus 1 minus cotangent?
Okay, because I used this guy. When I looked at this, I thought, where's something that has cosecants and cotangents together? And that's this guy.
Oh, okay.
So I know that one of these is the same as this. So I put him in that place. And then I just got subtract. Okay. Anybody think about anything different? How about just look at the numerator in the original problem? Okay, let's talk about that. I love that. Let me throw a piece of paper in here. Okay, so 1 minus cosine squared over sine squared. Yeah, this guy, okay, if you think about cosine squared plus sine squared equals 1, and that's where the Pythagorean identities kind of are fun because you can always like sort of mix them around. Cosine squared plus sine squared equals 1. So sine squared all by itself would be the same as 1 minus cosine squared. That's me just taking this guy and rearranging it. So 1 minus cosine squared is sine squared. And sine squared over sine squared, anything over itself, is 1. That's another way to do it. You could do a third way. You could replace 1 with sine squared plus cosine squared. And then the cosine squareds would subtract away. And so you would end up with sine squared over sine squared, which is 1. You could do this a lot of different ways. any way you do it, if you've done correct steps, we should all end up at the same place. Okay. If we end up with different stuff, then somebody did something wrong somewhere. Okay. There's only one correct, simple, well, that's a lot. We should all end up, if we twist it enough, we should all end up being able to end up at the same place. So if we can't, if you get to a dead end, if you end up with like a tangent and I ended up with a sign, then one of us took a wrong turn. Okay. So, Pythagorean identities, when I see things squared, when I see things adding and subtracting with ones, those are good clues that I might need Pythagorean identities. Okay. All right, I want you to try number 5 and number 6 yourself. You can get both of them down to a single function squared. You got to try something first. If you just sort of stare at it, nothing's going to happen. So just say, okay, what could I change first? What's something I could do? If you do something and and you're like, I don't know what to do next, and you get stuck, then start over. I know you guys don't like, well, students in general, not you guys specifically, but you guys generically, you students generically, you all do not like to write things down that you don't know are correct. You don't like to make mistakes. I mean, that's human. I don't think that's students. I think that's human. None of us want to make mistakes. That's a really big part of this, is sometimes you're going to make a mistake and do something and it's not the best way to do it. And it's going to be messy, and then you're going to have to try something else. And you kind of have to just be okay with that. It's much better to not erase everything, to just kind of like put a little X over it and start over, because we might want to go back and look at what you were doing. You may have been on the right path. It's hard for me to help you if I can never see any work. If you hand me the blank paper and go, I don't know what I'm doing, I'll be like, show me what you do know. You have to show me some stuff. You have to show me what you wrote, and then I can figure out how to help you guide your thinking. Okay. Anybody start inside the parentheses in number 5? Okay, yeah. I think that's what a lot of us are like, okay, well, it's inside parentheses. Let's see if I can change it. Inside the parentheses is a good place to start. Some of you might have thought about distributing. That's going to look a little scary. You can do it that way, but eventually you're going to have to. Yeah, that will not be your friend. You won't like that way. Distributing is not always the best plan. So changing a sum or a difference into a single term is a good plan. 1 minus something, can you make it into some single term? 1 plus something, this plus this. If you can take a sum or a difference out and replace it with one thing, a lot of times that's a good plan. All right. So somebody who started inside the parentheses, what did you do? You used the first Pythagorean one, and what did you do?
It's cosine squared theta, or x.
Oh, so, okay, so you looked at this, and you went, okay, if cosine squared plus sine squared is 1, then cosine squared is 1 minus sine squared. That sounds good. That sounds like that is a good helpful. So what's inside the parentheses, we could just change into just a cosine. So that's a better problem. Now what?
Well, I changed the tan square of sine square x over cosine x.
Okay.
And that's what
So using our strategy of, hey, maybe let me shoot for all sines and cosines. If I'm kind of stuck with what else to do, let me see if all sines and cosines reveal something canceling. So a sine squared over a cosine squared times a cosine squared. Yep, the cosines will divide. Sometimes it's scary, for sure, when we do this with like trig functions, because we're like, it's just a lot of writing. Same thing, kind of like back when we were factoring. So, you know, if we were writing, you know, if we had that, a over b times b over 1, the b's would divide away and we would be left with a over 1 or a. That's exactly what we just did when we took a sine squared over a cosine squared times a cosine squared. It's a lot scarier when they're trig functions with powers on them, but, you know, I know you know that those guys cancel out. I know that you know this. I know that. And you know that too. You just have to believe in yourself. Okay. All right, what about number 6? Number 6 has my favorite thing to do. I see cosine squared plus sine squared, I go 1. Cosine squared plus sine squared, 1. Do that first. And one thing at a time is a good plan. Don't try to do too many things at one time. So if you're like, okay, I'm gonna make one, if that might help you, it's just like, I'm gonna make one change and see what that does. So one change. Cosine squared plus sine squared is 1. Anything else we can do? I mean, if that's not a bad answer, but if we prefer sines and cosines, then that maybe is a better answer. This is the kind of problem where when we're doing this as a proof, it'll be a little easier because I'll be telling you, okay, I want you to make this one into a sine squared. I'll say, show me that this guy simplifies to this. All right, let's see how much further we've got. Oh, okay, so we're going to have a whole nother page. All right, so let's do 7 and 8. And then based on that, I will give you some of the problems to work on for practice. Okay. So these are combinations of different things. When I see 1 over something squared, I think 1 over anything, I think reciprocal, but especially 1 over something squared. Okay. When I see sine over cosine, I think tangent. So see what you can do with these last two. Then I'm going to give you some specific ones to do on the practice worksheet. Those I need. Okay. Okay. The more pieces we have, the tougher it gets. Okay. So big fractions, I like to change those if I can. If I can get rid of the fractions and have single functions, sometimes that's easier. So when I looked at number 7, that was kind of the first thing that stood out to me, is sine over cosine is tangent. So I might do that first. Now that looks kind of stressful to me, but when I see this, just that, I think maybe there's gonna be something Pythagorean in my final answer. So I kind of changed that. Let's talk about this. What happens when I take a tangent and a cotangent? What?
What I did was I switched it to the sine over cosine.
Okay.
And then the cosine over sine. And
Right.
They cancel each other out to get one.
Great. Excellent. So yeah, so tangent and cotangent are reciprocals. So tangent times cotangent makes 1. Cotangent is 1 over tangent, or tangent is 1 over cotangent, or, and this is a lot of people do, like, okay, I just want sines and cosines. So if you do that, you go, oh, well, they're reciprocals of each other. The sines cancel and the cosines cancel. And, you know, when stuff cancels, it doesn't make a 0. Everybody that cancels makes a 1. You multiply all those 1s together and you get a 1. And so then tangent squared plus 1. So secant squared would be the answer I'd be looking for on number 7. When we do a problem like that as a proof, the only difference will be, I'm just going to make a little note here, if it was a proof problem, I would say, hey guys, I have sine squared over cosine squared plus tangent squared, oh, not tangent squared, plus, whoops, tangent x, cotangent x. And I might say, show me that you can turn it into that. When we do it as a proof, we have a goal, and we have a side where we do our work, and we're trying to make our work side look like our goal side. Okay? We change one side to match the other. It's super helpful when we're actually doing a proof and we have a goal, because then we can start thinking, as I start doing something over this, like when I do that first, maybe, and I leave that there, then I can sort of look at that guy and go, oh, hey, yeah, that looks kind of almost perfect, because if I could just establish that that was 1, which I can, then I would have this. And that guy is that. When we do a proof, we'll know when we're done, because the two sides will be identical. One side will match the other. We work on one side to get it to match the other. Okay, that's kind of the rules of doing a proof. We can't do stuff to both sides at the same time, because that assumes that they're equal, and that we don't use a property of being equal to prove that things are equal. So if I want to prove that this big scary thing equals this thing, I got to work on this independently, do a bunch of work over here, and show from this step to this step to this step to this step that this expression on this side was equal to that. That's the only difference that will happen when the proofs happen. All right, so this is... Can you prove to me that number 8 equals negative 1?
There can be negative ones?
Hmm?
There can be negative ones?
Mhm.
Oh, okay.
Talk to me how you would show me that that could equal negative 1. What kind of changes would you make? If we were trying to get, so trying to show something equals 1 or negative 1, that's usually means I'm ultimately going to be thinking Pythagorean. Pythagorean identities don't have fractions in them though. So maybe 1 over cotangent squared into tangent squared, and 1 over cosine squared into secant squared. Now this is the one you kind of go, is it right? Is it 1? Is it negative 1? The way I usually talk about this is I think about, okay, tangent squared would be equal to secant squared minus 1. And so then the secant squared would subtract away. The different versions of the Pythagorean identities can make this a little harder. So what you might want to do as part of your memorizing or part of your strategy, we always have like strategies for these, right? We've got these 3 Pythagorean identities. I think what I would do is I would write the other versions down. So I'd be like, well, this is the one version of this guy. So another version is that sine squared is 1 minus cosine squared. And the third version is that cosine squared is 1 minus sine squared. That group I usually can handle. The ones that I always get confused about is this one. I forget which order makes it 1. So if you have 1 by itself, the secant minus the tangent squared makes the 1. But if you have it flipped around, that makes the negative 1. I don't have I have to think about a good trick for that. I usually just memorize this one and then and then under it I rearrange it. I think, okay, so if I move the cotangent over here, that would make that subtraction. So then if I flip that subtraction around, I get it going the other way. Okay. We're going through these lessons and getting to an assessment relatively quickly, which means you have to be doing the practicing. If you're not doing the practicing, you're going to get lost really quickly. So, on worksheet number 1, which is, we haven't finished the note part yet, but when we get to the worksheet 1 part, you should be able to do 1 through 10 and number 15 using what we talked about today. Okay. We'll talk about some of the other algebra things that we're going to do and do some more of the simplifying on Wednesday. Yes.
I have a whole test from last year.
Okay. Thank you.